Hello students, and welcome to the third lecture in the air pollution series. We're going to focus on acid deposition in this lecture. The lower photo shows acid rain damage to a forest, and the upper photos all show acid rain damage to structures that people have made. All right, so why do we call it acid deposition instead of acid rain? It's called acid deposition because it's more than just rain. It can be in the form of acid snow, acid dust, or acid gas. And in fact, if we were doing our usual labs in class, we would be having an acid gas lab where we would produce it in little petri dishes and see how it affects different materials. What's the definition of it? It's anything with a pH lower than 5.6, which seems pretty acidic because you think, well, isn't water is neutral at pH 7? So why 5.6? And that's because air is always going to be a little bit acidic because of the natural carbon dioxide in the air. So you only go into the acid atmosphere category when your deposition is lower than what would normally be there because of our carbon dioxide that occurs naturally in the atmosphere. So lower than 5.6. And over here you can see a little chart that shows different pHs of various different items. Remember, the lower the number, the more acid it is. If you go above 7, you go into the alkaline territory. So anything below 5.1 can be harmful to terrestrial ecosystems. This is just another little chart just showing you that it is what happens at various levels of acid. I'm going to call it acid rain because deposition is kind of a mouthful, but severe leaf damage, if you go below 3, leaf lesions, acid rain that they've, like pH levels they've seen over Britain, and then levels where fish start to really suffer if you get acid lakes, etc. And then, so even though this is anything underneath 5.6, you start to affect ecosystems right at that 5.6 level. So it's a widespread problem, but again, you're going to find it in areas where you get lots of transportation and lots of, in particular, industry. So anywhere you're downwind of industrial areas, you are going to potentially get that acid deposition. If your industrial areas are using things like steel industry, which uses a lot of coal plants, etc. All right, so I'm just going to show you a series of maps because, again, the good news with air pollution is that we've kind of come a long way. This is a map from 1994, and you can see that some of the acid rain from precipitation happening in the Northeast. This is the steel belt. Also, it's where a lot of our coal plants are. You can see that the deposition was down into the low 4s. 4.2 is quite acidic, versus we might have somewhat acidic rain out here, but in generally not nearly as bad. And even as you look around the areas, notice that even a lot of the green areas in the United States are below that 5.6 level. So a lot of areas getting affected, just maybe not very much. But again, that northeastern United States has a lot of acid deposition. Here's a map from 2001, and you can see the pictures a little bit better, but we still go down into 4.2, 4.3 in some of these areas. And the most impacted parts of the United States as far as our ecosystems are the forests of the northeastern United States, the Appalachians, the White Mountains and Green Mountains of Vermont and New Hampshire, the Catskill Mountains in New York. Those are going to be the areas that are going to see the most acid rain damage. But let me show you one from 2005. You can see this one gets better again. So again, very few. We only have, I can see this one at 4.3. But in general, again, the levels are not as low. What's interesting is I went online looking for a more recent map than 2005, and they must have stopped producing these because I couldn't find any. But I imagine that the picture's even better today because between 2005 and 2020, where we are right now, our use of coal has gone down a lot. We are still making a lot of steel, but our use of coal to make electricity has dropped a lot in the last 15 years. So what are your deposition prone areas? So I've already mentioned a few of these. If you're downwind, so winds generally blow from west to east in the United States. So if you are east from an industrial area, you're going to be more at risk. If you have thin soil, so when it says, I should really say prone, like the acid deposition damage prone areas, you can get acid rain in any kind of soil, but your thin soils are going to suffer more in the life living in those thin soils if they are already acidic, and so they don't have a lot of ability to buffer if more acid falls on them, and if they are thin. So often mountain soils are very thin because you're basically making soil on top of the rocks. And if your soils have lots of calcium, if they're kind of lime-based soils anyway, they might also be more able to buffer the acid rain than if you have already an acid soil. So if your native soils are acidic, And generally, how do you tell? If they carry lots of coniferous trees, which we have in this area, you have an acidic soil. And our soils in the Pacific Northwest do tend to be acidic. And then if you're like, imagine our Cascade Mountains and all of the snow that's up there in the wintertime, and then imagine you get a super warm weekend like we did this last weekend and you melt a whole lot of snow at once. It can cause something called acid shock when all of that acid that's been building up over the wintertime goes into those water systems. So just realize that is something, I mentioned it out here. We don't have as much acidic precipitation out here, but imagine on the East Coast if you have a really quick snow melt like that. What are the damage? All right, so where are you going to see this? Anything you make out of calcium carbonate. What do we make out of calcium carbonate? Anything we make out of marble. Marble is a beautiful stone, but it's pure calcium carbonate. Limestone is another one. We build a lot of buildings out of limestone, but if we're going to make art, we tend to do it out of marble. It's a metamorphic form of limestone, and it's beautiful. You might have marble bathrooms or countertops at your house, and if you have them in your kitchen, be very careful never to spill vinegar or anything else acidic in your kitchen because it will etch. So marble statues, tombstones, etc., that sit out in an acidic environment for a long period of time will start to dissolve. Acids also dissolve and corrode metals. This is one of the most striking pictures to me. The statue was built in 1702, and this first picture was taken in 1968. So in 266 years, if I'm doing my math right, she, suffered some damage, but it wasn't like, you can still tell it's a lady. But look at I'm sorry, this first picture was taken in 1908. So in 200 years, she had suffered some damage, but you can still tell who she was. It wasn't terrible. In just 60 more years, this from 1908 to 1968, this is what happened to her. And again, this is from the Industrial Revolution that started in the 1800s, and by the early 1900s was full underway. So you can see what all of that extra sulfur that we were putting up in the atmosphere, mainly through the burning of coal, did to our atmosphere, which then produced that acid rain that caused all this damage. So a few more slides. You can get something called spalling, where whole layers flake off, and then just again, you can look at the amounts of damage that happened at various statues. We've talked about this one in another class, lectures on climate change. But realize that our plankton, corals, and shells of marine organisms are also made out of calcium carbonate. And if they're freshwater organisms and that lake gets a big influx of acid, say from like a snow melt or something, that can cause a lot of damage. And then also realize that the shells of birds and reptiles are also made out of calcium carbonate. So they can also be damaged if they're exposed to a highly acidic environment. And it doesn't just always have to be rain or snow. Realize that there's something called acid gas, that if the atmosphere itself is acidic, you're going to have those eggs exposed to that acid, even if they're not getting rained on, say if they're in a sheltered nest. What does it do to forests? And so you saw in that other slide that it said it can cause leaf scorch, leaf lesions, etc., but that's actually not the way that forests die because of acid rain. The forests die because of what happens to the soil. So we're going to go through that in the next couple of slides. What you've got your sources of your primary pollutants that go up in the atmosphere. They react to make the secondary pollutants like sulfur dioxide, making sulfuric acid, and then that rains and that comes down into the soil. So why does that kill your forest? In the soil, and this is kind of a busy picture, but the nutrients that you need for your plants to survive are metals. They're things like calcium, potassium, magnesium, and those metals are dissolved in things that are acid. So metals dissolve, and what happens is that they get leached away. So those metals that the plants need to survive are basically washed away with the groundwater, the acidic groundwater, and then the plants cannot grow very well. You can also directly damage the leaves and roots of the plants, but if they're not getting the nutrients they need to survive, they're going to suffer. So you can also destroy things that are symbiotic that help the trees survive. And then the other one is that aluminum is quite toxic, and if it's mobilized, so aluminum is a really common element. It's found in a lot of rocks. If you start leaching that aluminum out of the rocks and putting it in your soil, that can also really damage your plants. And then what happens? So then you've got a few bad things happening. So the acids go into the soil, leach all your nutrients out so that your plants, trees, etc. die. But then where do those metals go? Well, those metals then go off in the groundwater and eventually make it into some water body. So the water body then gets an excess of these metals, which in high levels, and especially for a lot of animals, are going to be toxic. So you've got a double whammy here. You've got the soils getting leached of the nutrients where you want them to be so the plants can use them to help them grow. And you put those metals into the water body where you've now got a toxic lake. So just a few more things. Areas that are fairly going to be sensitive, tropical rainforests, they're going to be really sensitive because they've got poor soils already. Remember, they soak up, they take a lot of their nutrients, et cetera, and it's in the biomass. And so their soils are generally thin and not super great to begin with. So if you start removing the nutrients that are left through acid rain, the tropical rainforests are going to suffer. Boreal forests are also at risk because their soils, they're coniferous forests, and their soils are already naturally acidic. So here are some areas again. So anywhere you're downwind, so you've got your industrial areas in Europe, downwind of that, you have your industrial areas in the US, and actually Toronto, Canada is pretty bad, and you've got areas downwind of that. So, and you've got other areas also where you have a lot of industry happening that you're gonna have acid rain problems. So this is from Miller. What are our solutions? If you're gonna if you have a property that's, gonna be suffering acid damage, you can add lime to neutralize, or if you're a farmer. Problem is, if you're a farmer, lime's a rock. You have to buy an awful lot of lime or lime dust to put down on your fields, and it's a temporary solution. It can neutralize any acid that goes down, but then if you keep adding acid, you're gonna have to keep adding lime. So better do prevention. Just stop using the things that actually produce that acid rain in the first place. And that is the third lecture of our air pollution lecture series. Next will be part 4, which will be the final part in our air pollution lecture series.